Like all things, stars too have a lifetime, and the way they die depends on their size. Throughout its life, a star burns the hydrogen contents of its core. Larger stars burn out faster than smaller ones. This is called fusion. At one point, the star runs out of its fuel, which is hydrogen, and it starts making up all kinds of elements, which is oxygen, helium. It reaches a point where it creates iron. Iron is quite a heavy element. It requires a lot more energy than it can produce, and the core gradually loses its ability to burn. It shrinks down to the point where it starts collapsing on itself. This is called a star going nova. The size of the star decides its death. A smaller star can shrink to about 6 miles wide, or the size of the Earth, the end result being a white dwarf. This happens when electrons are far apart to prevent complete collapse. When stars 4 to 8 times the size of the Sun explode in a violent supernova, their outer layers can blow off in an often spectacular display, leaving behind a small dense core that continues to collapse. Gravity presses the material in on itself so tightly that protons and electrons combine to make neutrons, yielding the name neutron stars. When a star 10 times larger than the Sun collapses, the mass is too much for the core to withhold. An explosion called the supernova takes place. Through this explosion, a singularity is formed, which then gradually expands to form a black hole. Black holes consist of three parts: outermost layer, the inner layer, and the centermost layer. The outermost layer, the outer event horizon, has a weaker gravitational pull. The inner event horizon, the mid layer, has a stronger pull, and the singularity, which contains most of the mass, has the highest gravitational pull. If any person or object were to reach the black hole, and if they went inside the outer event horizon, the outermost layer, they could still escape as the gravity is weak. However, going past that confirms a certain death for any person and a loss of any object, as the gravity in the singularity and the inner event horizon is extremely intense. Though an extremely rare yet violent happening, black holes that exist close to one another can collide at one point due to their intense gravitational pull. The collision is so intense that it sends out gravitational waves into space. These are capable of altering space's time fabric. Gravitational waves were felt for the first time on December 2015 on Earth. The result of the two black hole collision is called a binary black hole. The irony is that the black hole, which is formed from the star, can easily take down any star, as the gravitational pull is so intense that any object in space cannot stand against it.